Hi, today I am teaching 5.2 frames and machines. What we have here is a little guy. We're going to call him Ben. Right there, there's Ben. We want Ben to lift up his 100-pound weight. Right? And he's going to use this crate system, this machine. Right? It's got 3 pulleys and a lot of ropes. And we want to know if Ben can do it. Okay? Ben's just a little boy. We don't know if he can't lift 100 pounds. So we're hoping that the force that he has to pull is less than 100. Okay? But we want to calculate it. We want to calculate how much weight Ben has to pull to get the 100 pounds over here to lift. Each pulley is 10 pounds. Okay? And as you can see, the ropes are intertwined, and this is the ceiling, right? The pulley A is connected to the ceiling, and so is pulley C. But the big thing that we're gonna rely on here is this right here. The P, which is the push, the force that is exerted on one of these ropes on a pulley, right, is equal on the other side. So if Ben was pulling on this pulley right here, the force that he exerts is the same as the force exerted over here, and double up here. Okay, so this is double, is 2P, that's 1P, and that's 1P. All based off of if someone was pulling on a rope over here. And so what I did here, I kind of started a free body diagram of each pulley, and we're going to start with A. We're going to draw a free body diagram of pulley A. Okay, so what I did here, I drew a free body diagram of pulley A. We're gonna call the P's on this side, on coming down from pulley A, PA. Okay, they're the same on each side. Okay, and the weight is 10 pounds, so that's also pulling down. Those are all the forces that are going down in the Y direction. It's connected to the ceiling, right? So the ceiling is going to pull back on it to hold it up, no matter how much force you pull down on. So no matter how much, if the pulley was 50 pounds and we had a huge number for PA, it would be 50 plus 2 PA. I mean, the ceiling is, I guess hopefully, the ceiling is strong enough to hold up whatever pulley A exerts down. And so that's why this up here, we know that it's the difference, right? Everything down here is being pulled up there. And so I'm going to draw a free body diagram of pulley B. Okay, so I drew a free body diagram of point B. Its weight is 10 pounds, right? That's going down. And PB is the big question. Okay? PB is what we want to know. This is that. Okay? And this PB right here is what Ben is pulling. And so we want to know, that's the number we're looking for, PB. And so I wrote, everything's the same, okay? Except I wrote PA up here, right? And that only makes sense with the context of the problem, okay? This PA right here, this line right here, right there, is this one right here, PA. Okay, it's going down when you look at the free body diagram of A. It's the same line as right here. Okay, so you can say that the force right here is the same as PA. Okay, so I'm going to draw a free body diagram of C. Okay, the pulley C is a little bit different than pulley A and pulley B. Okay, there's a weight, right? 10 is the weight of the pulley, and 100 is the weight of our object. Okay, so it's 110. I wrote it as 10 plus 100 just so you can see that it's 10 and 100. But that's the only thing going down. Okay, it's upside down kind of, the pulley, you can kind of see. Like these pulleys, the P's are going down, but this pulley, the P's are going up. These ropes are pulling it up. And so really I could write PC over here, right? But I know that it's PB. I know that it's PB because it shares this rope, right? This rope right here is the same as this rope right, this rope right here, right, is the same as this rope right here, okay? And since this rope is PB, that means this rope is PB, right? Likewise, this rope right here is PA, which means this rope right here is PA. It's the same rope. These two ropes are the same. And so, what I did there with the free body diagrams are super conceptual. When you're working with frames and machines, the problems are super specific, and you have to use a lot of skills that you've built up at recognizing, you know, this is PA instead of 2PC. You know, I mean, it's a lot of conceptual problems like this where you have to throw the skills that you've built at it. And so actually, the free body diagram of point A, or of pulley A, we don't even need it for the math. All we need it for is for the concept, okay? So that we can write point A, PA right here and PA right there. And then in turn relate PA to PB. And so we're not even going to use this free body diagram in our math. All we need is the B and the C. And what we're going to do is we're going to solve for PB. Okay? That's what we want to know. How much weight is Ben pulling? We're going to find PA in the meantime, but all we need is PB for this type of problem, this conceptual, specific problem, machine, right? And so I'm gonna sum forces. That is really bad. I'm going to sum forces in the Y for PB. Okay? Forces in the Y direction for B. We have a positive PA. We have negative 2 PB, I'm sorry. Then we have a negative 10, 0. Okay. We're also going to sum forces in the Y for C. Okay, we have a positive PA. We have a positive 2 PB. And we have a negative 110. All equal to 0. Okay, and so when you do the math for this stuff, okay, you're going to get that PB is equal to 25 pounds. And so what that's saying is that Ben only has to exert 25 pounds of force to pull up this 100-pound weight, which makes sense. I mean, this pulley system, this machine, should help Ben. It shouldn't be more than 100. It should be less than 100. And it happens to be 4 times less than 100. If you follow the ropes, other ways, and there's always other ways to solve machines than the one that you choose. But this case, this works. This method is just a lot of skills, being thrown at this problem. This right here is a nice one to remember. A pulley being that the ropes down here are the same, and the rope up top is double that of the force being exerted on the ropes on the bottom. But yeah, so I'm using bottom, the word bottom, but really, I mean, like this, for example, pulley C, it's not, these 2 ropes aren't on the bottom, they're on the top. But these ropes that swivel around the pulley, right, are the same, okay? And the force that the pulley is exerting on the rope connected to it, right, is double that of the ropes that are swiveling around. I hope that makes some sense. But this picture is accurately portraying what I just said. So just rely on this picture for any machine problem with pulleys. But this is how much force Ben's gonna have to exert, and he can do it. Ben's a strong kid. So, but that's all.